Okay, make sure you write down the title of your notes right there. Get that started, pause the video. We're going to start with 61A. So copy down both of these equations. It does say to graph both of these equations on the same set of axes. So let's do that. X squared minus 2x minus 8. So set up your graph, pause it if you have to. I'm lucky enough I got mine here, so I'm going to write it over here. Y, remember f of x is the same as y. So y equals x squared minus 2x minus 8. This is a quadratic, so I want to convert this to graphing form. That way we can tell what the locator point is, and it makes it easier for us to graph. We're going to do that by completing the square. Add 8 to both sides. Now let's complete the square. Half the b term squared is 1, so I'm going to add 1 to both sides. So y plus 9 equals, this factored is x minus 1 squared, and then I'm just going to subtract that 9 back. So now I have this in graphing form. You can see the locator point is at 1, negative 9. Okay, so obviously I didn't leave enough space there, so let me erase and zoom out a little bit. Looks a little bit better. Okay, so the locator point is 1, negative 9. My a term was 1 as well. So we're going to graph this guy by going right 1, up 1 squared. Symmetry, right 2, up 2 squared, which is 4. A symmetrical point. And then right 3, up 3 squared, which is 9. That gets me to the x-axis, and those are our x-intercepts. And you can see the shape of the graph. Go ahead and graph our nice curved U shape. Do the best that you can. Alright, and then the other one was just graphing y equals negative 2.5x minus 3. Well, that's from integrated 1. That's y equals mx plus b, graphing a line. So that would be, if I change this to a fraction, that would be negative 5 half x minus 3. I'm going to graph that one in a different color so you can see the difference. Negative 3 is our y-intercept, and then it's a negative slope, so down 5 and then right 2. So you can see there's an intercept right there. Okay, and then I can also go up 5, left 2 as well. And then you can see the shape of the line. Grab your straight edge. Let's get those lined up. Let's graph a line. And there you go. There's the graph. And I believe the next question says estimate the intercepts. Where the two graphs intersect. So this one doesn't need much estimation. It looks like that one's going to be exactly 2, negative 8. This one you might have to, like mine's a little bit crooked, but on your graph just kind of estimate what those intercepts would be, or maybe it's exact, I'm not sure. So go ahead and estimate on your own. Okay, so let's go back to what it says. It says how many times do the graphs intersect? So obviously you can see from our graph that they're going to intersect twice. C, estimate the points of intersection, and that's what we just talked about. Okay, let's go down to 62. Now we're not going to do anything in 62, we're just going to talk about it real quick. It says using a graph to determine the intersection of two curves can be challenging when the points of intersection are not where the grid lines intersect or are outside of the visible portion of the graph. So sometimes it can be hard to tell what the exact intersection points are. Therefore, it helps to have another method for determining the points of intersection. What algebraic methods do you guys know how to solve systems of equations? So from integrated 1, you should remember that you can solve systems by the elimination method, the substitution method, or the equal values method. So you can see in this these two equations here, B says use one of the methods in A to solve. So remember, these are just the same as Y. So we can set these equal to each other because Y equals both of them. So let's do that. Make sure you have 62 in your notes. Let's say x squared minus 2x. Here, let me get some more space here. I'm going to write up here. X squared minus 2x minus 8 is equal to, remember I converted this one to a fraction. Fractions are better. Okay, so negative 5 halves x minus 3. Alright, and then we're just going to solve this for x. So this is a quadratic equation. So we want to set this equal to 0, and hopefully it's factorable. Okay, so we're going to do that by, well, the first thing I want to do is get rid of this fraction. So I can multiply this entire equation by 2, and that'll eliminate that one fraction. So that gives me 2x squared minus 4x minus 16 equals negative 5 halves times 2 is just negative 5. So negative 5x, and then that's going to be negative 6. Now I'm going to add 5x and add 6 to both sides. So that gives me 2x squared plus x minus 10 is equal to 0. Okay, so now hopefully this guy is factorable because that's one of the methods for solving a quadratic. So let's try and factor this guy. I'm going to use an area model this time. Okay, so 2x squared negative 10, and then we're looking for what? Negative 20x squared, and then add 1x. So hopefully you're thinking here, what times what is negative 20 adds to make 1? I am thinking 5x and negative 4x. I think that works. 5x, negative 4x, which gives me x here, 2x here, negative 2 there, and plus 5 here. So it is factorable. So we're going to say 2x plus 5 times x minus 2 equals 0. Use your zero product property then. So 2x plus 5 is equal to 0. So x is going to be negative 5 halves. I'm skipping some steps there because I'm assuming you know how to do that. And then x equals 2. So those are our two values for x. So those are just half of the intersection points. We need the other halves, which is the y coordinates. So we're going to take both of these coordinates for x and we're going to substitute them in and figure out what our y values are. Okay. So I'm just going to use the original equation. This one looks easier than this one because I'm not dealing with fractions. So I'm going to say over here, I'm going to say y equals x squared minus 2x minus 8, and I'm going to substitute both of my x coordinates in and get some y values. So let's do 2 first. So 2 squared minus 2 times 2 minus 8. So that gives me 4 minus 8, which is just negative 8. So there you go. There's one of those coordinates. Remember from the graph, it intersected when x was 2, y was negative 8. There's an intersection point. So now we're going to do the same exact thing for negative 5 halves. So I'm going to plug in negative 5 halves, and I'm going to square it, and then I'm going to do minus 2 times negative 5 halves, and then minus 8. Kind of a pain here. You might want to use a calculator. I'm running out of space too, so I'm going to get, if I square that, I'm going to get negative 25, or that's going to be positive, I'm sorry, over 4. And then this is also going to be positive, so that's going to give me 5 if I do that, and then minus 8. And then I can just add these all up by getting a common denominator. So 5 is the same as 20 over 4. Okay, and then 8 is the same as 32 over 4. So if I add those up, that gives me, let's see, 25 plus 20 is 45, and then minus 32. So that's 13/4 when I do that correctly. Hopefully that's right. If you put it into a calculator, that should give you 3.25, which is just 3 1/4. So that is our second coordinate, which would be when x is negative 5 halves. When I substitute that in, I get a y coordinate of 3.25, or 3 1/4, or 13/4. So those are the two solutions for this system of inequations. It's where the parabola and the line both intersect at two different points, those 2 points. Okay, so that's that one. So it says consider the, so here, let's clear that off a little bit. Okay, so let's go to 63 and let's work on that one. It says consider the equations y equals x squared and y equals 2x minus 5. Sketch graphs on both equations on the same set of axes and estimate the point of intersection. Set up a graph and go ahead and graph those. See if you can graph those without my help. Okay? To make it a little speedier, I'm just going to drop the graphs in here. Okay, so let me zoom in a little bit. That's better. So it was x squared and 2x minus 5. So let's get y equals x squared. Hopefully you did that on your own. And then we also have y equals 2x minus 5. There you go. So it says estimate a point of intersection. Well, you can see it doesn't look like they intersect at all. So there you go. That'll be your answer for that one. All right, and then it says use algebra to solve a system of equations. Okay, well, y is equal to both expressions, x squared and 2x minus 5. So I'm going to set them equal to each other, equal values method. So let's say x squared is equal to 2x minus 5. You guys should know that we should be setting this equal to 0 and keeping x squared positive. So I'm going to subtract 2x and add 5 to both sides. And then when I rewrite it, I'm going to have x squared minus 2x plus 5 equals 0. And then I always tell you guys, try and factor from here. So what times what is 5 adds to make negative 2. Hopefully you're thinking nothing, because that would be correct. So this is not factorable. So I'm going to use the, I'm going to complete the square here, just instead of factor. So let's subtract 5 from both sides to complete the square. So x squared minus 2x, and then remember I'm going to add some value for c, that'll complete the square, equals negative 5. Half the b term squared is 1, so I'm going to add 1 to both sides. So this factored is x minus 1 squared equals negative 4. Hopefully you're thinking to solve for x, we're going to square root both sides. You would be correct. Now here's the issue. We can do that, but if you look right here, we have the square root of a negative, right? So remember, we used to say no solution, but now we say plus or minus 2i, but all that really means is that there are no real solutions, which means that, you know, technically for what we're answering for this graph, there are no solutions, which means y equals x squared and y equals 2x minus 5 don't intersect on a graph. And we confirmed that in the beginning when we sketched them as well. Go ahead and skip a line, and let's practice one more for 64, and then let's try it out here. So let's try, maybe I'll pick one of the harder ones, okay? So how about we try C right here, okay? So it says in the instructions here, it says use an algebraic method of your choice to determine the points of intersection. So we're not going to graph, we're just going to set these equal to each other because y equals both. Alright, so let's do that. So we have y equals, so we have x squared, again I'm doing c, minus 4x plus 5, and that's going to be equal to the other one because they both equal y. Negative x squared plus 4x and then minus 1. Alright, this is a quadratic, so let's set it equal to 0. So I want to keep x squared positive, so I'm going to add x squared to both sides. I'm going to subtract 4x from both sides, and then I'm going to add 1 to both sides. Let's do that. So that obviously this is all going to be eliminated, and that'll be 0. So now we have 2x squared, and then that gives me minus 8x, and then plus 6 equals 0. Always try factoring first. It looks like we do have a greatest common factor between the three terms, which is 2. Let's factor that out. Minus 4x and then plus 3 equals 0. And that looks familiar to me. I'm pretty sure we can factor that guy now. So x and x, what are you guys thinking? What times what's 3? Makes negative 4 when we add them, right? So hopefully you're thinking negative 3, negative 1, you'd be right. Now let's use the zero product property. So what makes this be 0? Hopefully you're thinking x equals 3. There's 1. And then x equals 1. There's 1. So that tells you right there, since we're getting 2 answers for x, that means that there are 2 intersection points for the graph. Let's substitute those x coordinates back in to either of the original 2 equations, so this one or this one, to get our y values. I think the top one looks easier, so I'm going to substitute it in for that one. So y equals x, so I'm going to do 3, so 3 squared minus 4 times 3 plus 5. So that gives me 9 minus 12 plus 5, which is 2. So y equals 2. So that tells me my intersection point is 3, 2. There's one of them. I'm going to do it again for the other one. Y equals, so 1 squared minus 4 times 1, and then plus 5. Sorry, running out of space. So y equals 1 minus 4 plus 5, and that would also be 2. So it looks like 3, 2, and 1, 2, it looks like. I hopefully didn't make a mistake in here. 1 minus 4, negative 3, I've got 2. No, it looks good. So 1, 2 is another intersection point. And those are the solutions. That's where both of these parabolas will intersect, is at 3, 2, and 1, 2. Let's go confirm that real quick. Actually, I'm running out of time. I'm about 5 seconds short, guys. Thanks.